This is the test review guide for the Algebra 2 Unit 9 exponential and logarithmic functions. And this first question asks you just to rewrite each expression. If it's in exponential notation, you want to write it in logarithmic notation and vice versa. And basically, you want to take an expression that has this the exponential format, and you want to make it look like this, and you want to take the one that looks like that, and you want to make it look like that. So basically back and forth. So let's start with the first one. We want to write this in logarithmic form, and remember that whatever number is the base of the exponent becomes the base of the logarithm. So this is going to be log base 3. And remember that your base of the logarithm is written as a subscript. Just like an exponent is written a little bit smaller and up, the base of the logarithm is written just a little bit smaller and down in approximately the same position as an exponent would be up. So the log base 3, that's not the input though, so you need an input, and the input is always the thing that the exponential expression is equal to. And so this is log base 3 of 19, and the log expression is always equal to whatever is the exponent. So it's log base 3 of 19 equals x. So in the next one, doing the same process, the base of, let me erase all the scribbling I did. So the log base is the same as the base of the exponent. So this is going to be log base 5. And the input of the logarithm is the thing that's on the opposite side of the equal sign from the exponent. So it's log base 5 of y. And it always is equal to whatever the exponent is. So log base 5 of y equals m. Now in letters C and D, you're given a logarithmic expression, and you want to rewrite that in exponential form. And again, let me get rid of my scribblies here. And so the base of the logarithm is always going to be the base of the exponent, so 7. And then remember that it's kind of like a swish, so you go like that. And or you can think of it as a curly Q, but from the base of the log across the equal sign and back over to the exponent. And that's the order that you write the things in. So it's 7 to the 24th power is equal to x. And then in this next one, it might help you to rewrite this instead of the 8 equals being at the beginning, to take this and say equals 8, like that. If you write it like that, then in that way you can think about that curly Q, and then your answer here would be x to the 8th power equals 35. Now, in your calculator, these next several problems, literally, all you need to do is grab your calculator and press buttons and write down what the calculator says. We're not actually asking you to ponder or think about or remember anything for these except what buttons to press. So remember that if you are asked to evaluate a logarithm that does not have a written base, there's no small number right here, then that's automatically log base 10. So you're thinking here is log base 10 of 13. But in your calculator, there's a button that has that log without a written base. It's called the common logarithm. And that button with the base 10 is on the left-hand side of your calculator, and it's, I think, the 4th button up. So on, then store, then ln, then log. That button means log base 10. So when you type that into the calculator, just press that log button. But in the calculator, what it'll do is give you log, and then it'll give you open parentheses. And you just type the 13, and you can press enter there, or you can put close parentheses. If there's nothing else in the expression that you're typing in, the calculator will assume that you're done without the close parentheses. And it should give you like 1.1139 and so on and so forth. And remember that for Miss Abelbacher, you just want to round to 2 decimal places. And so that's going to be 1.11. The button immediately below the common log button is ln, or the natural logarithm. And that works the same way in your calculator. You find the ln button, it gives you automatically the open parentheses, and then you just type 9 and hit enter. And when you do that, you should get something. It's got like 2.19722 and so on. And again, I want you to round to 2 decimal places. Remember that if it's a 9 and you have to round up, then you have to go back 1. And so your answer here is going to be 2.20. I still want that second decimal place, but 19 rounds up to 20. And so your answer here is 2.20. Now, for the logarithms that have a base other than 10 or the natural logarithm, when you see a number written here, that you're going to need to use a few more key presses. And so to get that, you want to press alpha, which is that green button higher up on the left. And then you want to press window, which is in the top row. And then you want choice number 5, so alpha, window, and then the number 5. And when you do that, it gives you like a logarithm with a little box with a blinky here and a little box here, actually inside parentheses. And so you're going to go ahead and type the 7 there, and then you have to right arrow, and then you can type the 53 here. And then you can press enter, and when you do that, you should get something like 2.040326 or something, and so round that to 2 decimal places, and you've got 2.04. In letter D, you type D in the same as C, where you use the alpha, window, 5. Type your 3 for the base of the logarithm, and then right arrow and type a 1, and your answer should be 0, exactly 0. And if that feels weird to you, remember to think about it the other way around, that it's 3 to what power equals 1, and if you put a 0 as an exponent on any number, that automatically makes the expression equal to 1. So again, letter E, you're going to type in like you did C and D, where you use alpha, window, 5, and type the base and type the input, and you should get 1.25 after you round. And then for letter F, remember that you want to use that button that's called the caret. That is near the clear button. It's between clear and divide. And then you just type the 1.6 immediately after pressing that caret, and it'll automatically appear as an exponent like it is given in the problem here. And so your answer to that would be 13.13. Now for letter G, you can type in the parentheses. If you start by typing the open parentheses, and then do your alpha y equals, and then enter. It'll give you the fraction, and you can type 2 over 3. Then you have to do right arrow, type the closing parentheses, and then you can type the 4 as the exponent. And if you do that, it'll give you your answer as a fraction, 16 over 81. Or if you want to, you can type in parentheses 2 and then divide by, and then 3 and then parentheses, and then do caret and then 4, like that. And when you do that, you should get a decimal answer, and that decimal answer would be 0.1975. So when you round that, it would be 0.20. And I would take either answer. And for letter H, literally type in what you see. 5 parentheses 3 parentheses to the 4th power, just exactly like that. And when you hit enter, it should give you the answer 405. Now you caught me in the morning drinking coffee. Surprise, surprise. So in number 3, you want to draw a circle around the things that are exponential. So draw a circle around exponential expressions or functions or graphs. And you want to draw, I'm trying to find different colors. You want to draw a box around anything that's logarithmic. Let's start with the logarithmic, because the equations should be straightforward, because they have either the word log or the word ln, and it's not going to have anything else. It's not going to be different. It might have other stuff being added or subtracted or multiplied or divided, but it has to have the word log or the word ln in order for it to be a logarithmic function. And then the exponential functions are the ones where you have an x in the exponent. So, for example, in this one right here, 5 minus 3 to the 2x power, that's got an x in the exponent, therefore it's exponential. But if you look at all the rest of them, this doesn't have an x in the exponent. This only has numbers as exponents. This doesn't even have an x inside the radical. This has a number as an exponent, and this one has an x in a denominator. And so really, this is the only equation that we have, the 5 minus 3 to the 2x power, that is exponential. Now, when it comes to graphs, first let's start with the one that's not. So the one that has an endpoint. So the second graph right here, that has an endpoint, and that's a square root graph, which is not exponential or logarithmic. Only the square root graph has an endpoint like that. And so therefore, that's not going to be one of our answers. If you look at the other 3 graphs, they're all either exponential or logarithmic. And what you need to look at is the placement of the asymptote. And so in this first one, I see that there's an asymptote here. And that's y equals -4. In the third one, I see that there's an asymptote here at x equals -3. And in this last one, I see that there's an asymptote here at y equals positive 3. And so when I zoom back out, do you see that the first and the fourth should be the same type of function because they both have a horizontal asymptote? And the third should be the other type of function because it has a different type of asymptote. You have to memorize that exponential functions have a horizontal asymptote and logarithmic functions have a vertical asymptote. And so this is exponential, and then the third one is logarithmic. When you're taking your test, if there's a question like this on it, be very, very, very sure to be clear as to the difference between a box and a circle. Make sure that your box has definite corners, like sharp edges on it, and that your circles are completely round and not boxy looking, or vice versa. If I can't tell by looking at it, I will mark it wrong. Now, for this next section, you're evaluating these functions, and note that the directions say show all substitutions. And so before you start typing anything into your calculator, what we're going to want you to do here is rewrite. So the function that you're given is this thing, and you're evaluating it at f of 8. And so you want to rewrite the function f of 8 equals negative 3 times 2 to the 8 minus 5 plus 1 power. And the only thing that you did was replace the x with the x with the 8 from the function notation. And then that thing right here is what you type into your calculator, and type it exactly the way you see it. So you type in negative 3 times 2, and then you use the little caret button for 8 minus 5, and then use a right arrow to get back down so that you can type plus 1. And your answer should be negative 23. But when you write that, remember to write f of 8 equals negative 23. And yes, one more time, I do need to see this step because it says show all substitutions, and that's your substitution step. In the middle one here, you're evaluating this function for f of 3. And so I'm going to start by showing my substitutions. So f of 3 equals 7 minus log base 2 of 5 times 3 minus 1 inside the parentheses. And I can type this in exactly like this, but remember that for the log base 2, you need to use your alpha window 5 to get that different base. Do not just use the log button because it assumes log base 10 and this is log base 2. So when you type all of that in, you should get f of 3 equals, and then I get a big long decimal number with a lot of digits, 3.192645. And so you're going to round it to 2 decimal places, 3.19. The next digit is a 2, so you leave the 19 the way they are. And so that's letter B. And then in letter C, again, I'm going to write the substitution out. So f of negative 3 equals 5 times ln of 7 minus negative 3 plus 2. Then I'm going to type exactly that into my calculator, and remember that ln is a button all by itself over on the left, the third button up from the bottom. So type in 5 times ln, and then it gives you the parentheses. Type 7 minus negative 3. Remember that the minus and the negative are 2 different buttons. And then plus 2. And you should get that f of negative 3 is 13.51. Now for this problem on the bottom of the page, remember that with multiple choice problems, before you go trying to compute anything or trying to figure out the math of the problem, look at the answer choices that are available to you. So this asks me about what is the graph of log base 3 of x, and before I freak out about it, I don't know how to tell if it's base 3. Notice that all 4 of these graphs represent different types of functions. So really the question is asking which one is the logarithmic graph, not which one is base 3. So if you look at this more closely, this first graph in letter A is a rational function. So that's rational. Well, that's not logarithmic, so it can't be A. In letter B, well, I'll come back to it because B is going to be your answer, but in letter C, notice that you have a horizontal asymptote at 0. Well, that's going to be an exponential function. And then notice in letter D that you've got the end behavior going very sharply or steeply up and down really fast, both on the left and on the right. And therefore, this is going to be a polynomial function. And if you recognize the shape, you know that this is probably cubic. And so let's go back to letter B. The way that you can tell that B is logarithmic is that it has a vertical asymptote here, and a logarithmic function has one asymptote and it's a vertical asymptote. So your correct answer B is the logarithmic function. By the way, just so you know, that the way you can tell that this is logarithmic, that it's base 3, is if you look at the point that is 1, 0, and then move away from the asymptote, the point that's 1 unit away, 1 unit this way, and then you're measuring it that way, 1, 2, 3. So this point is 1, 0, and this point here is 3, 1. That 3 right there, that's the base of your logarithm. So that means that it's log base 3. Log base 3 of x. Now, for numbers 6 through 11, these are matching problems, and it's a good approach to matching to kind of use process of elimination. And so start by noticing that for these, for each of these equations here, the base with the exponent on it is either 2 or it's 1/2. 3 of them are 2 and 3 of them are 1/2. And so start by looking at your calculator and just graph y equals 2 to the x and y equals parentheses 1/2 parentheses to the x. And just graph those two functions and look at the difference in shape. And you'll see that y equals 2 to the x is increasing from left to right, and that y equals 1/2 to the x is decreasing from left to right. So what that says to me is that of those 6 graphs, I can basically match 6, 9, and 11 with B, D, and E, and I can match 7, 8, and 10 with A, C, and F, just based on the shape and the increasing, decreasing aspect. And so then what I want to do next is look at any of the transformations. So I'll just start with the graphs that I highlighted with the blue. And the first one, number 6, the first equation here is the parent function without any shifts at all. And so if I look at B, D, and E, remember that the parent function of the exponential curve has a point at 0, 1. So here's 0, 1, here's 0, 1, here's 0, 1. So I'm thinking it's E. The point should also have the graph should also have a point at 1, A or 1, base. And so here's the point 1, 2. And so you have a point at 0, 1, you have a point at 1, 2. So the answer to letter 6 is going to be E. Now I'm going to skip down to number 9, and that takes the parent function and shifts it down 1. And if you look at letter D, and specifically look at the asymptote, that asymptote shifted down 1. And so your answer for number 9 is D. And that just leaves me with 11 is B. And notice that in the equation, that shows a shift to the right 1. And this graph in B shifted to the right 1. So now let's look at the graphs that have the parent graph of 1/2 to the x power. And all of these graphs should have a point, if the parent function for all of the graphs should have a point at 0, 1, whether it's 1/2 to the x or 2 to the x. And so if I look at those 3 green graphs, here I've got a point at 0, 1, here I do not have a point at 0, 1, and here I do not have a point at 0, 1. And so my parent graph, which is going to be number 10, should be graph A. And then for number 7, it's shifted down 1, and so C is shifted down 1. And so that's going to be C there, and that leaves me with F for number 8, and that's a shift again to the right 1, and you can see on this graph that it's shifted to the right 1. Now, for number 12, you're asked to list the transformations and give the domain and range. So if I look at the equation here, I see one transformation there, and I see another transformation there. And the one in the top, x minus 32, that's going to be your shift left or right. Remember that insiders lie, and that's your insider. And so minus is going to be a shift to the right. So this is shift right, 32. And then the plus 25, that's an outsider. And so that's going to, outsiders don't lie. So that's going to be a shift up 25. Now, for the domain, there's a couple ways that you can do this. You can graph the equation that you see there, but it's going to be difficult to see in the window of your calculator. The other way that you could do this is you can graph just y equals 5 to the x power, the parent graph, and what you'll see is a graph that looks just like the parent function of all the exponential curves. And then you can consider moving that, shifting it to the right and shifting it up, and what would change about the domain and range. Well, for every exponential function, and if you need to make a note about this to yourself, note that for all exponential functions, domain is all real numbers. And so if it's an exponential function, your domain is all real numbers, and you don't really have to think about what the graph says. But then you're asked about the range. And remember that over here to the left, I drew the graph of y equals 5 to the x. I did not draw the graph of the function that's given with the shifts. Well, if I took this graph that I drew, which it has a range of 0 to infinity, if I shifted that up 25, then my range instead is going to be 25 to infinity. So 25, round parentheses, because there's an asymptote at 25, it's not actually going to touch 25, and it goes up to infinity. Now in number 13, it's asking the question in reverse, basically. So they're giving you the transformations and want you to write the equation. So you need to make a few observations. First of all, your parent function is log base 5 of x. That's not going to be the answer to the question here, because the question is really asking you to write the transformed function. So what we're going to do here is we're going to say that the transformed function is shifting up 213 and shifting left 41. And there's a third transformation this time, and that is that it's reflected over the x-axis. And so when I go to write my answer for this, and it asks us to use g of x. So your transformed function equation is g of x equals, I'm going to start with the reflection over the x-axis. That's going to be negative, and then grab that log base 5. And then you're going to put something in parentheses and something outside of parentheses. And so remember that the left-right shift is the one that's inside. Insiders lie, and so this is going to be x plus 41 inside the parentheses. And then I'm going to go ahead and erase that arrow. I'm not sure how the video is going to construe that. It may just not be there at all for you ever. But what I'm going to do then outside of the parentheses is I'm going to deal with the shifting up 213. So plus 213. And so that's your function. And what you might want to do before you do the domain and range, if you were to graph this crazy function with x plus 41 and plus 213, it's not going to show on the screen of your calculator. But then what you can do is just graph the log base 5 of x without those shifts. But I would include the reflection over the x-axis. So I'd grab my calculator and I would graph y equals negative log base 5 of x. Don't worry about the shifts. You can kind of imagine those as you go. But if you graph y equals log base negative, let's say that again. If you graph y equals negative log base 5 of x, and again, you're going to need to remember to use, for the base of 5, you're going to need to remember to use alpha and then window and then number 5. When you've done that and you type the x inside the parentheses, hit zoom 6, and what you're going to see is that the graph ends up doing this, and you should see there the flip, because if it didn't flip, the graph would be kind of like this. Okay, that's the graph without the flip. So the graph with the flip is the one that goes down, or the first one that I drew. And so the domain is here 0, 0 to positive infinity, and the range is all real numbers. So if you take that graph and you shift it up the shifting up doesn't change the domain or the range, but the shifting left 41 would take this blue graph and shift it to the left 41 units. So instead of the asymptote, let's make that asymptote red, instead of the asymptote being at 0, the asymptote is going to be at y equals negative 41. And so that graph would end up being like what I just drew in red there. And so now we can do the domain and range, and the domain would be that negative 41 with a round parentheses because it doesn't touch negative 41. There's an asymptote there. Negative 41 to infinity. And then the range would be all real numbers. So any logarithmic function, no matter what the transformations and shifts are, the range is all real numbers. Now, why don't you go ahead and clear your calculator before you start drawing the graphs at the bottom of this page. Excuse me. And go to y equals, and we'll start with 14a. And in y equals, if you wanted to type this with a dot instead of parentheses, you can type this like 3 times and it'll give you a dot, or no, I'm sorry, it'll give you the asterisk 3 times and then 2 to the x power. Use the caret to get the x. Remember that you have to then right arrow to type +1. And so put this in y equals, y1 equals, all of that. And then once you've typed that into y1 equals, press the graph button just to get a look at it so that you can see basically that your graph is going to look kind of like this. And then press second graph to actually see the table of values. And notice that in second graph, if you scroll up to some of the bigger negative numbers, you'll find that the numbers are positive, but they're like 1 point something. And even if you keep going and going and going and going, it's like 1.0 something, 1.00 something, 1.0000, but it's never actually going to reach 0. And so that's going to be your asymptote there. So you're going to have an asymptote at y equals 1 here, like that. And then if you graph points that are close to being whole numbers or actually whole numbers, you'll see that there's a point at -1, 2.5. So -1, 2.5. And just to kind of bring it out a little bit, at -5, it's like 1.09, and at -3, let's just say roughly it's about 1.3, so you can kind of start to see the shape. Then at 0, your point is 4, and when x is 1, y is 7, and I think that x equals 2 I can fit on here. So at x equals 2, y is 13, and that's going to be the last one that I have room to put on here. And then when you draw your graph, be careful not to actually touch that asymptote there. And then up here, this is kind of hard to do, but let's see here. There you go. And so your graph should look more or less like that. Hopefully you've got a steadier hand than I do. And so there's your first graph, 14a. And now I would go ahead and clear the calculator and type in, go to y1 equals and type this in. And again, I would say type it exactly the way you see it here. So use, don't forget your negative, and then type alpha, apparently can't spell, alpha y equals, and then enter, and it'll give you the fraction. Type your 1 over 2, but use the parentheses, use the caret button for the x plus 1, and go up to x plus 1, but then you have to right arrow to get the plus 7 in there. And so I'm typing it as I'm talking to you, and I didn't keep up with my typing and my talking. So plus 7. And then when you, just to look at the graph, either zoom 6 or just press graph, and what you'll see is the flip from that minus sign out in front, and the shift up, very obviously from the plus 7. And so your graph here in the screen right now should look something more or less like this. Okay, and hopefully you can see that the asymptote would be up here at y equals 7. And so I'm going to go ahead and draw an asymptote at y equals 7 right there. And I'll go ahead and label that y equals 7. And then I'm going to do second graph to look at my table of values. And this time, because I entered a fraction, it gives me fraction values. And if you want to avoid having those fraction values, they're a little bit trickier to graph. You can go back to y equals, and instead of the 1/2, you can do 0.5. And then if you go back to your table of values, now you should have decimals. And what I find is that at -6, it's way off the graph, -25. So when x is -6, y is -25, I can't graph that. And the graph space that I gave you, you can't even graph x is -5, y is -9. But the next point that you have that you can graph is when x is -4, y is -1. When x is -3, y is +3. That's going up pretty fast. That's the whole point of exponential functions. When x is -2, y is 5. When x is -1, y is 6. And from there, you have decimals that start with 6 points and then getting closer and closer to 7, but never actually reaching 7. So at 5, at 0, it's 6.5, and it keeps just getting closer to the asymptote like that. So when you draw that, draw yourself a nice smooth curve that doesn't quite touch the asymptote. And let's see if I can make a nice smooth curve here. Oh, look at that. I'm almost satisfied with that graph. The funny thing is on this app, when I draw zoomed in, it makes the line really skinny when I zoom out. But if I draw it at the same, I'm not changing the width of the pen. It changes with the zoom in and zoom out. So I zoomed in to draw parts of those graphs, and it ended up making the graph look skinny. But I can't help it. You get the picture. So there's your graph for letter B. Go ahead and clear your calculator again, and we'll draw the graph for letter C. Go to the y equals window, and remember to get that log with a different base. What you're going to do is to get the base 3, you want to do alpha window and then number 5. Remember that when you type the x plus 1, you have to right arrow to get outside of the parentheses in order to type the -2. And so as I did before, I'm just catching up with what I'm saying and typing. So now I'm going to do zoom 6 or just hit graph to look at the graph. And when you do that for this one, you should see some crazy thing, like it ends up looking like this. And notice that almost looks like a square root button. because the calculator doesn't know what to do with that part of the graph. Because remember that the logarithmic graph goes close to a vertical asymptote, and your vertical asymptote here would be like here. And that graph needs to be drawn so that you show me that you have an understanding that that graph does that, because your calculator isn't as good at processing the logarithmic graphs, because they have that very steep slope in the part that goes near the asymptote. And because it's vertical, the calculator says, oh, that's not a function. We can't do things that aren't a function. Whereas in your head, you know that it's a function. So I need you to finish drawing that whole graph. If you only draw what you see in the calculator, I will take off some credit for that. You need to know off of the top of your head that you have a graph that keeps going, even though the calculator doesn't show it. So the asymptote I drew over there was at x equals -1. And so let's draw in the asymptote at x equals -1. It's a vertical asymptote. We just talked about that. And then do second graph to look at the table of values. And I see that at 0, it's -2. Notice that everything to the left of that says error. Well, it's really to the left of -1. And so it's -1 and all the numbers past that. But because the calculator doesn't give you intermediary values or values between the different integers, it's only going to show the error at -1 and a number at 0, and you have to know that the graph keeps going. I'll say that a few more times just to intentionally annoy you. When x is 2, y is -1, and then I'm going to scroll down till I see another whole number, and at 8, x is 0. And let's see if I can find another whole number that's graphable. And the next time I get to a whole number is 26, 1, and I didn't make the graph go that far. So again, I'm going to say, remember that the graph goes down toward the asymptote. You have to draw that part even though you can't see it on your calculator. And then going to the right, this graph is going to look like that. I really want to make this neater over here. Sorry, I'm kind of like that. And so there you have the graph for part C. So I'm recording this video on, gosh, what day is it? Friday, April 19th. And I just got a tornado watch on my phone, which is next to the iPad, for now through midnight. So if you're actually watching this video, it probably means that I did not get blown away like Dorothy to Oz, and I'm not walking on the yellow brick road, and I'm not seeing the man behind the curtain or failing to see the man behind the curtain. And if you don't know what I'm talking about, get a video and watch The Wizard of Oz. And having said all that, just be thankful that I'm not going to sing, because now that I'm thinking about Follow the Yellow Brick Road, I might just break out into singing. So anyway, also that's to say that the rain is supposed to start soon, and it's supposed to come with thunder, and so there may be thunder in the background in the video, and really, I'm not going to pause the video or re-record it if there's thunder. So it might just be me talking and then boom, and then me talking some more and then boom. Just a warning. So here we go. What I'm doing in order to answer, in fact, let me zoom back out a second. So each of these problems in 15 through 22 asks you to find there's several things that you're asked to find here. You're asked to find zeros and the equation of the asymptotes and the domain and the range of each. And so you're looking for 4 things. And what I would do really is, for the first 4 problems, graph those in your calculator, just so that you get a feel for what the graph actually looks like. And so as I start number 15, I'm going to graph that in my calculator, and that graph of the logarithmic function base e in the calculator looks like this, but remember that you know that it looks like this in all actuality, okay? And so the first thing that it asks you to find is the zeros. And you could use the computation functions in the calculator, which we'll use in a minute on a couple of the other problems, to find the x-intercept. Remember, 0 is x-intercept. But what I'm going to say is that you know that this is a parent function because based on the equation, there's no transformations of any kind. And you know that every parent graph of the parent logarithmic function has the point 1 comma 0. Every single logarithmic graph that doesn't have any shifts has to go through the point 1 comma 0. That's your x-intercept. And so starting with that, then you have a 0 at x equals 1, or you could say 1 comma 0, I don't care which. Then all of the parent graphs of logarithmic functions have an asymptote, a vertical asymptote at x equals 0. And so the next question you're asked is about asymptotes. And so you have an asymptote at x equals 0. And then the next two pieces ask you for the domain and range. And the domain of the parent graph of any logarithmic function is 0 to positive infinity, and it's got round parentheses around the 0 because it never touches 0, because that's where the asymptote is. And then the range for every logarithmic function with or without shifts or transformations, the range is always going to be negative infinity to positive infinity. Now go ahead and pause the video for a second and graph this, draw the graph of this next function 2 plus, and then for the log base 4, use alpha window 5, type log base 4, x minus 1, and then zoom 6 to look at it. And what this graph should look like here is, it kind of looks like that, but remember that you know that the graph should continue. And so I need you to draw that bottom part. And so you're being asked to find the 0 of that. And what I would do to find the 0 is, and we'll do this a little bit in class, you need to really zoom in on the place where it touches the x-axis, because it's hard to do unless you zoom in. And so you can just use the zoom in function, but what I prefer, because it's a little bit more precise, is to do zoom 1, which is zoom box, and you have to draw the box on the screen. So when you click zoom 1, it brings you back to the screen, and you should see a little blinking point at 0, 0. And you want to kind of move that point over. So you're going to move it over to the right and down. And so instead of being at 0, 0, instead of being at 0, 0, I'm going to erase it there. That point moves to, let's put it like, I don't know, somewhere in there. Press enter, and then drag it to the right and up, and it'll draw this box, and then you click it again. So you have to click the two opposite corners of that box. And at this point, then, what you have is a box. The calculator will zoom in specifically, and you'll end up having a box that just shows the graph going through the x-axis. And so your screen now looks something like this. And now you can do your left bound, right bound. So you do second and then trace, and then number 2 for 0, do left bound and right bound. And then when it says guess, you press enter. And I wasn't keeping up with you. I actually have all this written out ahead of time and just want to make sure that I'm doing it correctly. So here, your 0 should be x equals, and the calculator gives you 1.0625. You can write all that out if you want, or you can just write 1.06. And then the next question you're asked about is the asymptotes. And remember that a logarithmic function has a vertical asymptote, and in this case, it's shifted over to the right one. And so that's going to be x equals +1. And then you're asked for the domain. And the domain goes from the asymptote at 1, but not including 1, to +infinity. And you're asked for the range. And the range of every logarithmic function is -infinity to +infinity. Now in number 17, when I type this into the calculator, I would put parentheses around the fraction. I know that the calculator sometimes eliminates parentheses if they're not necessary. It just helps me when I'm typing visualize where the exponent goes. And so go into y equals, type parentheses, and then do alpha y equals enter to type the 1/3. Remember that you need to put a right arrow to get out of the fraction. Type your closing parentheses, then type a caret for the x as the exponent, but then you have to type right arrow again to type the +4 on the outside, and then do zoom 6 to look at the graph. And what you should see in this graph is an exponential function that's decreasing and that has shifted up 4. And so the 0, can you tell when you look at this graph, let's go back up here, that if there's an asymptote here at y equals 4, that the space in between, that space in here, the graph is never going to go below that asymptote, and the x-intercept, or the 0, would have to be below the asymptote, and therefore there's not going to be an x-intercept. And so zeros, if it asks you for the zeros and there are no zeros, you have to say none. You have to answer the question. It also asks you for the asymptote, and we just said that it's y equals 4 because we shifted up 4, and it had been y equals 0 for the parent function. The domain of every exponential function is all real numbers. It's all real numbers because it's exponential, and the domain of every exponential function is all real numbers. But in this case, the range is from that asymptote up. So from the asymptote at 4 up to +infinity. So your range is going to be from the asymptote at 4 up to +infinity. Now, for this last one, again, I would clear my calculator, go back into y equals, type exactly what you see, but remember that in order to type E, you want to do second and then ln, which is near the bottom on the left. So 2 times, you have to type the 2 and the times, second ln, and the calculator puts the e, but it also takes your cursor to an exponent because you never use e without an exponent or a logarithm. So the calculator sets up the e with an exponent. Oh, excuse me. Type in your x minus 5 as the exponent, and then zoom 6 or press graph to look at the graph. And the graph that you should see is something like this. On the left, it's so close to the axis that you probably can't even distinguish it on your calculator. And then notice that the shift here in the equation is a shift to the left or right because that's an insider. Hint, it's a shift to the right. But because it doesn't shift up or down, the asymptote is going to be at y equals 0, and therefore there's not going to be an x-intercept. And so here, let's start with if there are any zeros, and you say none. And then you're asked about asymptotes. And that's going to be at y equals 0, we said. And then you want to give the domain and range. Remember that the domain of every exponential function is all real numbers, and that the range of this function goes from the asymptote to positive infinity. So the asymptote's at 0 to positive infinity. Now, for the functions where you're given the graph, the first thing that you want to do is try to identify where the asymptote is, and decide if it's a vertical or a horizontal asymptote. You really want to look for which one looks more like it straightens out at some point. And so in this first graph in number 19, I see that there's an asymptote right here, a vertical asymptote here at x equals 3. And for this graph, the first question that you're asked for these is what's the x-intercept, or what's the 0 of the function. And because you're not given an equation, you can't come up with an exact value of the 0, but that looks like it's partway between x equals 3 and x equals 4. So I'm just going to say that it has a 0 at x equals 3.5 or 3.5, that we said that it has an asymptote at x equals 3. That's that line right there, x equals 3. And then it asks for the domain and range. And here, because it's a logarithmic function, and you know that it's logarithmic because it has the vertical asymptote, the domain goes from the asymptote at 3 to infinity, but it's not including 3, so you use the round parentheses. And the range for every logarithmic function is all real numbers. In this second one, I see a horizontal asymptote right down here at y equals -1. And if I look closely, that x-intercept looks like it's pretty much exactly x equals -2. So let's say that there's a 0 at x equals -2. We said that there's an asymptote at y equals -1. Now, because it has a horizontal asymptote, it's an exponential function, and so your domain of every exponential function is going to be all real numbers. And your range is going to be from the asymptote at -1 to positive infinity. So your range is going to go from -1, not including -1, to positive infinity. That's a pretty lousy positive infinity. I think I'm going to erase that and make a better one. Oh, that wasn't so great either. We're going to stick with that. There's your positive infinity right there. And if you want a better one, sorry. In this next one, I also see a horizontal asymptote here right on the axis. So I'm seeing a horizontal asymptote here at y equals 0. And because there's a horizontal asymptote, it's an exponential function. And because that horizontal asymptote is 0 with an exponential function, there's no x-intercept, so there's no zeros, none. And your asymptote, we just said, is y equals 0. It's exponential, therefore your domain is all real numbers. And your range is going to be from the asymptote at 0 to positive infinity, and that's not including 0. And then for this last one, I didn't do a very good job of... So the graphing software that I use to draw the graphs is different from the graphing software in your calculator, but it still freaks out about the logarithmic functions. And you can see that on any of the graphs that I give you that are a logarithmic function, that I've had to use function in Word to kind of add length to that line so that it actually looks like a logarithmic function. And you can see there the place where the graphing software gave up and where Miss Applebacher stepped in, and clearly I didn't line up the line segment very well with the graph. And so therefore you can assume that this is a logarithmic function, and that it has an asymptote right here, and that is x equals -4. And so my answers to the questions, well, here's the x-intercept at -1, and so I've got a 0 at x equals -1. I've got an asymptote, like we just said, at x equals -4. And then for the logarithmic functions, your domain is restricted. So the domain goes from the asymptote at -4 to positive infinity. So the domain goes from -4 to positive infinity. And the range for logarithmic functions is always all real numbers. -infinity to positive infinity. Now, moving on to 23. 23 and 24 are regression problems, and remember that the SOL, the Virginia State, only requires you to know linear, quadratic, cubic, and quartic, and exponential regressions. And this unit is exponential and logarithmic functions. So any regression we give you is going to be exponential. Remember that on the SOL test, what they may do is just give you a table with data. So they may give you a table like this, not tell you that it's exponential or linear or quadratic, and that you need to be able to look at the scatter graph and decide which one is best, which one is the best, most appropriate model for the scatter graph that's given, and then go back in and calculate the equation based on that And if you want to see some examples of some scatter graphs that are of the different functions side by side, you have that in your notes for this unit. In that notes packet, it's I think the second last page has a bunch of scatter graphs, and it asks you to discern whether they're quadratic or linear or cubic or exponential. Anyway, whatever is on your test this week or next week is going to be an exponential regression. So just to kind of remind you of the steps that you need to take for the regression problems, the first thing that you want to do is clear your calculator. So remember that you want to start with second plus sign 712 to clear your calculator, and then go to stat and then press enter so that you get the list with the L1s and L2s, and you want to type whatever list that I give you in the first spot is L1, and whatever list I give you in the second spot is L2. And the L1 is going to be your X, and the L2 is going to be your Y, or the L1 is going to be your independent, and the L2 is going to be your dependent variable. So pause the video for a second and go ahead and type those numbers into your calculator. And once you've got those numbers typed into L1 and L2, double check them to make sure that you've typed them correctly, or you're going to find that your answers are off by a decimal. And then you want to press second y equals, and that gives you the stat plots. And then you want to press enter to choose plot 1, press enter again to turn it on, and then press zoom 9 to see the graph. And what I'm seeing when I do that is I'm seeing a graph that kind of looks is not even accurate. It is fairly clearly exponential. And so I'm seeing that just the scatter graph part of it. But the first question asks you to find the model. And remember that the word model here means you want to find the exponential equation, the regression equation that models or represents that data. And so the next thing that you're going to do in your calculator is go back to your stat button, and then you want to right arrow to calc, and then you want number 0. So just press the 0, or you can arrow down to 0, but it's the one that says EXP regression or EXP reg. And then remember that it gives you the screen with the X list, Y list, frequency list. You can just arrow down, so down, down, down. And then next to store regression equation, you want to type alpha trace and then enter. And what that does is it gives you the Y1 next to store regression equation. And then you're going to arrow down again to calculate and press enter. And then what you'll see in your calculator when you do that for this problem, the calculator will say something like this: y equals a asterisk b to the x power, and then a equals, and you have like a 4.305118043 and so on, and b equals 1.17148, all these digits. Okay, that's what your screen should say. And then what you want to do is round each of these to 2 decimal places. So you want to kind of get the 4.30, but that's going to be a 1, and 1.17, and write those as an equation. And so you're going to have y equals 4.31, put parentheses or a time sign, and then 1.17, that's your a and b, and then the 1.17 is to the x power. And that's the answer to part A that asks for the equation that represents the data, the exponential model that represents the data. Now, you're going to be asked two more questions. One is going to give you an x value and ask you to find the y value, and the other one's going to give you a y value and ask you to find the x value, and it may not be in that order. So you have to decide. In this question B here, the problem is saying to you, in the 12th decade, how many people will be living in that city? Well, it's giving you the decades, so that's x is equal to 12. And so to find that on your calculator, you're looking for the y value. And so you want to press graph so that you're seeing, you have to be able to see both the graph with the scatter graph as well as the line that goes, the line of the function that goes through it. And then you want to do second trace. And number 1 is value. And that's when you type in x equals 12. And when you do that, it gives you an error. And that's because you didn't have any x values that were as high as 12. And so your graph over here on the right doesn't go as high as 12. 12 would be over here somewhere. And so what you want to do is then go into the Windows settings, and you want to change X max to something bigger than 12. So I'm just going to go down to X max and make it 13. And then do the second trace, then go back and do second trace 1, value x equals 12 again. The second trace 1, and it's redrawing my graph. That's why I hesitated. And so x equals 12. And now it says to me that the y value is 28.761252 and so on. That's what my calculator says. And the question asks for the population in thousands. Miss Applebacher asks that you round decimal numbers to 2 decimal places. And so what you want to write for your answer is 28.76 thousand people. So in part C, it gives you, my apologies for not turning the sound on my phone off. I took a little bit of a break and forgot to turn the sound on the phone back. So for part C, they're giving you the number of people. So here, that's a y value, y equals 42,000, right? But you don't have to type in the 1,000. The 1,000 is just your units, your label. And you want to find the x value. So in order to do that, you want to go to your y equals menu, and you want to do y2. So you're going to arrow down to y2 and type in y2 equals 42. And when you do that, then press graph again. And I don't see anything. And so now you're going to have to go back to the window menu and make sure that your y min and y max include y equals 42. So I'm going to go to window, and it looks to me like my y max is 26 point something. And so I'm going to change y max to something bigger than 42. So how about 45? I'm going to change y max to 45. I'm going to redraw the graph. And this time, when the graph is drawn, what I'll get is both the scatter plot that is like an exponential function. I'll get the linear regression, or the exponential regression, and I'll also get the line at y equals 42. But notice, again, there's a problem because you can't see the intersection, and you need to see the intersection. So go back to the window and change it again. And this time you want to bring out your x max to something that's far enough that you can see the intersection between the two things that I have in the circle over here. You want to actually see those two things intersect. And so when I go to my window, I'm going to make my x max something kind of a lot bigger than it is. So let's make it 20. And then I'm going to regraph it. And this time when I draw the graph, what I should see here is the scatter graph and the exponential regression. And I also see that that line is the line y equals 42. And what I want to solve for is the place where those two graphs intersect. I want to know the x and y value of that intersection. So to find that, I'm going to do second trace and then number 5. And then I'm going to press enter, enter, enter. Can you hear my calculator clicking in the background? And when I do that, it shows me that the intersection is at x equals 14.39 and y equals 42. Well, we knew y equals 42. We're interested in that x number. And so our answer to this question is in the 14th decade. And if you want to put 14.39, that's fine. I would take that answer. I'm really looking to see, do you know how to do the regression? So that's number 23. I'm not going to write out all the steps again for 24. 24 essentially works the same way. I'll talk through the problem with you, but I expect you to be kind of pressing pause on the video to type some of the things in. So go ahead and start typing in the data in this table, excuse me, into your stat menu. Okay, so you're back. Do you have all that typed in? Remember that you want to look at the stat plot first just to kind of get a feel for the shape of it. And so when I typed all of this in, I kind of got my calculator screen looks like this. And it's got a lot more points than the previous graph. Okay, but it's clearly exponential. But the first question asks you to find the exponential model. So that means that you want to find the equation. So again, do the stat and then calc. And then you want 0 for exponential regression. Store regression equation is alpha trace. Enter to put that y1 there. And then click on calculate. And when you click on calculate, my A value is 1779.403 and my B value is 1.1206. And so the equation that will then go with that exponential model will be y equals, and write out the whole 1779 points and then round to 2 decimal places, 40, and include the 0 because it's a decimal value in the second place. And then the B value 1.12, and the next digit is 0, so you can just leave it at 12 to the x power, and that's your exponential equation. And the next question asks, based on this model, how many bacteria are going to be present after 12 hours? And ask yourself, is 12 an x value or a y value? And it's an x value, so here x equals 12. So you do second trace. Well, you want to look at the graph again first and see that the graph has the line and the scatter graph. And remember that it won't compute any values for your x and y values if you can't see both the scatter graph and the regression line. So I'm looking at the graph, and I know that I want to find the y value when x is 12, and so I'm going to do second trace 1 and type in x is 12, and again it gives me an error. That just means that the window isn't big enough, and so I'm going to go to window x max, and I'm going to change x max to something bigger than 12, and I'm going to make it 13. I'm going to click graph again to look at the graph, and it just pulled out the right end of the graph a bit. And now I'll do second trace 1 again and type in x equals 12. And this time it tells me that the y value is 6,981.02. And that's the number of bacteria that are present after 12 hours. And that sounds like everybody's going to get a cold. That's a lot of bacteria. I don't want those in my house. Okay, and so then it asks approximately when will 20,000 bacteria be present? I'm guessing that if y is equal to 20,000, that's going to be off my graph. So the first thing I'm going to do is go and see if my window settings include y equals 20,000. And right now my window settings have y up to 66,300. So I'm going to go ahead and change that to like, I don't know, 22,000 and then regraph it. So I've got all this white space up at the top. And I'm probably at some point going to need to go back and change the x value too. But let's get the line graphed. So go back to your y equals menu. Excuse me, arrow down to y2 equals. And type in that 20,000 for the y2. And then go back to your graph. And when I do that, what I see in mine is the scatter graph that kind of looks like this. And then the y equals 20,000 that looks like that. And I definitely have to draw out the x end of my graph, the x max. And so when I change my x max on mine, I found that x equals 25, x max equals 25 works really nicely. And so that graph then ends up connecting out there when I've brought out the x max to 25. And so in this case, you're going to do the second trace 5, enter to find the place where those two graphs intersect. And here I find that x is equal to 21.24 when y equals 20,000, and that means that at our 21.2 hours, or after 21.2 hours, there are going to be 20,000 bacteria. And again, I don't want all those bugs in my house because it sounds like I'm going to get a bad cold. Yeah. Did I sing anything from The Wizard of Oz yet? It definitely is in my head. You may not get through this video without me singing. And now for this last page, just kind of run through the graphical characteristics that you see on the graph that's presented to you. And the first thing that's going to be difficult about this kind of problem, again, and you've had a couple of questions like this already in this review, is that you want to distinguish between a logarithmic function graph and an exponential function graph. So before you start answering all the questions on the side, go ahead and try to figure out where the asymptotes are for each of these graphs. In fact, it might be best if you pause the video and make sure that you can see where those asymptotes go and whether they're horizontal, because each is going to have one asymptote. It's either going to be horizontal or vertical, but you're not going to have a graph with both. Go ahead, pause the video. And now you're back, and hopefully in this first graph, you drew a vertical asymptote here at x equals 0. And in the second graph, hopefully you drew a horizontal asymptote here at y equals -1. And so for the function family, a logarithmic graph or a logarithmic function has the vertical asymptote. And for the equation of the parent function, we haven't really talked a lot about how to find the base. And so I'm going to be content if you just list the base as b and then log base b of x. Notice, just in case you're curious, that the graph, this must be a parent function because it's got a point at 1, 0. And then this base is probably 1, 2, 3, 4, 5, 6, 7. I would say it's probably 8. Looks to me like there's a point at either 8 or 9. So let's say that this point is 8, comma 1. So that would mean that b equals 8 for this graph. But if you can't figure that out, don't worry, because all I'm asking is that on the test that you just put b as the base of the logarithm if I give you a graph and ask you for the parent function of the graph. We said that the asymptote is x equals 0. Because it's a parent function, the domain is going to be 0 to infinity. We've talked a little bit about domains already. For the logarithmic functions, the range is always all real numbers. We've already found that there's a 0 at x equals 1. And remember that zeros and x-intercepts are going to be the same number, so that the number that's x equals here is going to be the number that x is for the x-intercept. And then the y-intercept is not, it doesn't exist because there's the asymptote there, and so there's no y-intercept. The graph is increasing. If you're the ant and you're walking on the graph, you're increasing the whole time. And so your increase is going to be the same as the domain. So whatever is the domain, in this case, is going to be the interval of increase. And so that's going to be 0 to infinity. And it's increasing the whole time, so it's not decreasing anywhere. You're not going to have any max or mins for any of the points on that graph that doesn't change direction. And because it's logarithmic, you only have end behavior on one end, and that end is on the right. It's going to go to positive infinity. In the second graph, because it has a horizontal asymptote, the function family is exponential. And again, I'll say that I don't expect you to know the base at this point. We haven't talked about how to do that much in the notes. So just put base a to the x. And actually, for both of these, I think maybe I would rather, and I'm sorry that I wrote y equals, I think that I would rather have you write f of x equals. So let's go ahead and change that to f of x equals log base b of x in the first one, and then I'm going to change that to f of x equals a to the x. F of x equals a to the x. In that second graph. And just in case you're curious, this one's a little trickier, but if you really want to know how to find the base, look for that point. Now this graph has been shifted. Clearly it's been shifted down, and look for that point that would have been 1 unit away from the asymptote. And then moving away from the graph, look for the next x value, and that's 1, 2, 3, 4, 5, 6, 7 away from the asymptote, and so that would be 7 to the x power. So if you really wanted to know the equation, it's not 7 to the x power, actually it's 1/7 because it's backwards. It flipped over the y-axis, and I didn't write that very well, so 1/7 to the x power. If you don't understand anything about where I got the 7 or the 1/7 from, or the green stuff that I just drew on the graph, don't worry about that. Come back right over here. And we said that the asymptote is y equals -1. We already said that. Because it's exponential, the domain is going to be all real numbers. The range is going to go from the asymptote to positive infinity. We can see that there's a 0 at x equals 0, and so it goes through the x-axis at 0. If the x-intercept is 0, the y-intercept is also 0. That's the only point that is the case for. But if the x-intercept is the origin, then the y-intercept is also the origin. Okay, and this graph, if you look at it, if you're the ant and you start on the left of the graph, the whole graph, you're going downhill. Even out here where it looks like it levels off, it's still slightly going downhill. And so there's no increase whatsoever. The whole thing is decreasing, and it's decreasing over the domain. And so the domain is all real numbers. The decrease is all real numbers. There's not going to be any mins or maxes on this whole unit. Nothing with exponential or logarithmic functions has a min or a max. And let me start on the left end of this graph. Remember that this says on the left. On the left, the graph is up toward positive infinity. Remember that a horizontal asymptote always determines the end behavior. And so in this case, you have a horizontal asymptote over here that is the same as the end behavior. And so that number is -1. And so your horizontal, your right end behavior, as x goes to positive infinity, your graph goes to -1, which is the horizontal asymptote. Follow the yellow brick road. Follow the yellow brick road. Follow the yellow brick road. I just couldn't not sing it because it was in my head the whole time.